Okay, so I'm going to explain how to graph a rational function. So we're going to use this problem right here. So this problem is 3x minus 1 over x plus 2. So we're just going to go down the list here. So whole, there is no whole because there is no, so when you have a whole, that means that there's the same expression on the top and the bottom, and in which case you would cross out, and because these are totally different, where there's no holes, we're just going to put none. Okay, now moving on to the vertical asymptote. So the vertical asymptote is what's on the bottom, so x plus 2. So what you're going to do with that is you're just going to set it to 0. So x plus 2 equals 0, minus 2, you're just going to solve for x, so x equals negative 2. So what that means is we're going to draw a dotted line on negative 2 on this graph, so 1, 2. We're just going to draw a dotted line vertically. Perfect. Okay, so next we're going to move on to the horizontal asymptote, and the horizontal asymptote is basically the number next to the variable divided by the bottom. So it's going to be 3. So it's going to be whatever number is next to the x. So this is 1. So you're going to divide it top by bottom. So it's going to be, let's move that over here. So it's going to be 3 divided by 1. And 3 divided by 1 is 3. So that means that your horizontal asymptote is 3. So you're going to go to positive 3. So 1, 2, 3. And you're going to just draw a dotted line like you did for the other one. Okay, perfect. Now that you have your dotted lines, we're going to move on to the actual points. So zeros and x-intercept is actually the same thing. So we're just going to combine those all together. So zeros and x-intercept are the top of the equation. So 3x minus 1. So like that. So we're just going to be solving for, we're going to equal that to 0 and then solve for x. So it's going to be 3x minus 1 equals 0, plus 1, 3x equals 1, divided by 3, x equals 1 over 3. So with that point, you are going to graph that. So that means that basically you're graphing this point. So 1/3 is x and 0 is y. So you're going to go over to your graph and you're going to graph that. So it's about right here. Okay, perfect. Now you're going to find your y-intercept. So for finding your y-intercept, you're going to take this whole equation and you're going to set the x to be 0. So it's going to be 3 times 0 minus 1 over 0 plus 2. So 3 times 0 is 0, so cross that out. Negative 1 over 0 plus 2 is 2. So you're going to graph that point because this point is basically 0, negative 1, 2. Come on, 3. So you're going to graph that, so it's about right here. So now that you have your 2 points, you're going to create a line. So when you're creating this, you want to make sure that your line and points are all within the same dotted line area. So basically this just means that this is going to be like that, and then you're going to connect them like that. Okay. So now we're going to have to create another line like this in this quadrant here, like this dotted area. So to do that, we have to find points. So we have to make sure it's within like these dotted lines. So it has to be less than negative 2. So anything smaller than it, basically, it has to be higher than positive 3. So to do that, we're going to make a little chart over here of our x and our y. So we're just going to use, we're just going to use 6 as our x. So it's going to be 1, 2, 3, 6. It's going to be like right there. And then for our y, so to do that, we're going to take this equation and we're going to plug in that 6 for x. So it's going to be 3 times 6 minus 1 over 6 plus 2. So this is all going to equal, so 3 times 6 is 18. Minus 1 is 17 over 6 plus 2 is 8. So it's going to be 17 over 8. So that's going to be about, it's going to be about right here. So then you're just going to, again, put the lines together, and now you have your second line. So it's going to be 17 over 8. Okay, so now lastly for this problem, we just have to do the domain. So the domain is the x-axis, so this axis right here. So so in order to do that, we're gonna have to see where the interruptions are. So first, we're gonna start from negative, so it's gonna be negative infinity, and then we're gonna go all the way to our first interruption, which is right here on this -2 dotted line, so it's gonna be -2. And then you're gonna do union, and then -2, because that's where you left off from. And as you can see, there's no more interruptions, so it's just positive infinity. And that is how you that's how you graph a rational expression. Okay, so I'm gonna explain how to simplify a rational equation when dividing. So this problem that we have on the paper, m squared minus 2m minus 8 over 8m plus 24 divided by 2m minus 8 over m squared plus 7m plus 12. So the first step when simplifying a rational equation when dividing is you have to keep, change, flip. So what that means is you're gonna keep this equation as it is, change this to a multiplication sign, and flip this. So m squared plus 7m plus 12 is going to be on the top, and 2m minus 8 is going to be on the bottom. So it's going to look like this. So this equation stays the same, so keep, change that to that, and then flip. So m squared plus 7m plus 12 over 2m minus 8. Okay, so now what you want to do is you want to factor all the equations so you can see if you can cross out anything. So let's start with the top one here. So m squared minus 2m minus 8. So I know that 4 times 2 equals 8, and 4 minus 2 equals 2. So we can use those two numbers. So it'd be m minus 4, and then m plus 2, because -4 plus 2 will get you -8, and then add these together will get you -2. And then down here, so 8 is a factor of 24, so we're going to put that number on the outside, and then put m, and then 8 times 3 equals 24, so we're going to put it like that. And then we're going to do the same thing on the other side. So I know that 3 plus 4 equals 7, and 3 times 4 equals 12. So we're going to do m plus 4, and then m plus 3. Because 3 times 4 equals 12, and 3 plus 4 equals 7. So it's perfect. And now lastly, so I know 2 goes into 8, so we're going to put 2 on the outside, just like we do with this one. And then m, and then -4 times 2 equals 8, so we're going to put -4. Okay, now that we have it all factored out, we're going to look at diagonal we're going to look at the diagonal equations, and we're going to see if we can cross anything out. So basically, if something's the same, you can cross it out. So for example, m minus 4, there's one down here, and there's one up here. Diagonal, perfect, we can cross it out. Same thing over here, m plus 3, we can cross it out. Then now, you're left with m plus 2 and m plus 4. And then you're also left down here with 8 and 2. So you're just going to combine those. You're going to do m plus 2 times m plus 4. So that gets rid of these two because you're moving them down here. And then over 8 times 2 equals 16. And that is your final equation. That is how you simplify a rational expression when dividing. I'm going to be demonstrating how to simplify a rational expression when adding. So with our problem right here, whenever you're adding a rational expression, you want to make sure that the denominators of both equations are the same. So as you can see, this one is missing, they both have x plus 1, but this one is missing the x plus 5. So what we're going to do is we're going to times this side by x plus 5, and obviously whatever you do to the top, you're going to do to the bottom, and whatever you do to the bottom, you're going to do to the top. So once you're going to multiply that by that and that by that. So that means that you're going to get 3 times x plus 5 over x plus 5 times x plus 1. Then you got that plus, and then keep this all the same, so 4x over x plus 1 times x plus 5. Okay, so now that you have your denominators the same, you're going to combine this all together. So it's going to be 3 times x plus 5 plus 4x over x plus 5 times x plus 1. Now, as you can see, we can definitely simplify this equation more. So we're going to do this 3 times x plus 5. So first we're going to do 3 times x, which is 3x, and then 3 times 5, which is positive 15, and then plus 4x, and then all over x plus 5. And we can even simplify that even more because we have similar variables, so 4x and 3x. So we're going to add those together to get 7x, and then we're going to bring that 15 down here. So 7x plus 15 is what's going to be on the top. And then on the bottom, it's going to be x plus 5 over x plus 1. And that is how you simplify a rational expression when adding. Okay, so lastly, I'm going to show you how to solve a rational equation. So this is our equation, 2x over 3 equals 1 over 6. So like any other rational equation, you want to make sure that the denominators are the same. So we're going to keep this equation the same, and we're going to alter that one. So we know that 3 times 2 equals 6. So what we're going to do is to make this denominator equal to that one, we're going to times that by 2. And whatever you do to the bottom, you always have to do to the top. So we're going to times 2x by 2 as well. So now we're just going to do that out. So 2 times 2x gets you 4x, and then 2 times 3 equals 6. And then we're just going to equal that to 1 over 6. Okay, so now that both of the denominators are the same, we can just cross them out. They're gone. So now you're going to be left with 4x equals 1, and now you're just going to solve for x. So we're going to, in order to do that, you want to get x alone. So 4 is currently multiplying itself by x, so what you want to do is divide the x by 4. So you want to divide by 4, and then whatever you do on one side, you want to do to the other side. So you're going to divide 1 by 4, and then that crosses out, and then it's just x equals 1 over 4. And that is your answer. And that's how you solve a rational equation.